What do you know about algorithms? What do you think they are? How do they work? What impact do they have on you? Let's start with a game. Here's the first letter of a word. Can you guess the whole word? How confident are you in your guess? Here are two letters of the word. Has your guess changed? Are you more confident you're right? Here are four letters. By now, you've probably narrowed it down to just a few possibilities. Did you guess that the word was hippo? How did you guess? When you had only seen the first two letters, HI, you might have thought that history or hymn were more likely than hippo. Both are much more common words. What might have been some extra information that could have helped you guess that it was hippo and not one of those other words? For example, if you knew I liked hippos, or if you knew it was going to be the name of an animal. This might remind you of a kind of algorithm that you probably use every day, the autocorrect on your phone. It uses patterns to guess what word you're trying to type, and its guesses are more accurate if you type more letters and if you're typing a more common word. An algorithm is basically a series of steps or instructions for doing something. Some of the different things that algorithms are used for are sorting things, like search results, classifying things into different groups, matching different things, and filtering things out before you see them. If you have a social network account, for example, the company has already sorted you based on what they know or think they know about your age, your gender, your interests, and dozens or even hundreds of other bits of data. They use this to classify you into an audience, a group of people with similar tastes or interests, and to match you with recommended posts or videos and targeted ads. They also use the same data to filter out content that you won't be interested in, ads you probably won't respond to, and content that's against the terms of service. That may not seem so bad after all. If you have to see ads, it's better to see ones for things you're actually interested in. But because algorithms show us what they think we want to see, they can keep us from seeing the whole picture. You may miss an important post from one of your friends because the algorithm doesn't think you'll like it. You may not get the best or most reliable results from a search engine because its algorithm thinks you'll be more interested in different sources. Algorithms on social networks and video sites also usually prefer whatever people have interacted with the most, which means that hoaxes, conspiracy theories, and misinformation often spread more easily than reliable information, and the loudest voices can seem like the majority. Besides the different types of algorithms, they can also be optimized for different effects. For instance, a video site's Up Next or For You algorithm might be optimized for one of these purposes. To make its decisions, an algorithm will rank or weight different factors. For example, here are some of the different things that a video site like YouTube or TikTok might consider when deciding which videos to recommend to you. How many views a video has gotten, how many likes a video has gotten, whether it's getting more popular quickly and recently, how many people have shared the video on the site, how many people have linked to the video on other sites, and how many subscribers the video maker has. These won't all count equally. Depending on what the platform has been optimized for, some will count for more than others, and some might not count at all. When we're interacting with an algorithm, we don't always know that we're giving it information. Explicit inputs are those which we know we're giving and have a choice about. A good example of an explicit input is the like button. In most social networks, Clicking like tells the algorithm to show you more content like this. Implicit inputs are ones you provide without knowing that you're doing it, like how long you watch a video. Algorithms also draw on things like your browsing history to determine what you're likely to respond to, and e-commerce sites often set higher prices if you're using an Apple device. Implicit inputs are typically weighted more heavily than explicit ones. For instance, while clicking like does have an impact on platforms like Twitter and Instagram, TikTok's algorithm actually appears to ignore it. One of the reasons why TikTok has been so successful is not really due to its algorithm, which is nothing groundbreaking. Rather, it's the result of how its design encourages users to interact with the algorithm by making it easy to show that you don't like something by swiping it, or that you do like it. All you have to do is keep watching. Many platforms like YouTube and Google let you turn off algorithmic targeting and recommendation. Others like TikTok go a step further and let you retrain their algorithm. As well as helping you out if you've fallen into a rabbit hole, it can make for an interesting experiment if you try to consciously train it for particular kinds of content. If you have a TikTok account, start by going to your settings, then click on Content Preferences and select the Refresh Your For You Feed option. Then click Refresh and you'll start over with a blank slate. To do this on YouTube, go to myactivity.google.com and click on Manage Your Watch History. Click Delete Activity and then All Time. Now you can start to consciously retrain your algorithm. As an experiment, you can try to get TikTok or YouTube to only show you one kind of content, all cat videos, for example. How long will it take? What works better, liking videos, watching them all the way to the end, or something else? If it gives you options for negative feedback like not interested or don't recommend buttons, test how well those work at weeding out the content you don't want to see. Now let's talk about artificial intelligence, or AI. What does that term mean to you? Machine learning algorithms, which are sometimes called artificial intelligence, process huge amounts of data to find connections that people wouldn't necessarily notice, then use those to make inferences or guesses. If a guess seems to work out, it will become a rule. Based on what you know about algorithms and AI, do you think AIs have feelings? AIs can feel hurt or left out. AIs can choose to do or not do things. AIs are smart. AIs always give you correct information. AIs know if they're giving you correct information or not. AIs can think about whether something is right or wrong. A lot of people are unsure about these things. In one study, a quarter of 11-year-olds thought that Alexa, a smart speaker that uses AI, has feelings and can think for itself, and another third thought these were maybe true. AI tools definitely seem to be intelligent, thus the term artificial intelligence, and may even seem to have feelings. They can seem very smart, and they do make decisions. For example, they may refuse to do something you tell them to, and if you ask them a question, they'll choose what to include or leave out in the answer. While the good or harm done by any technology is primarily the result of how it's used, the nature of that technology also shapes how we use it. This is particularly the case with algorithms for two reasons. First, as we've already seen, because how they operate and how we interact with them is often invisible to us. And second, as we'll see in this section, because machine learning algorithms in particular resist our understanding. Using algorithms makes decisions more consistent, and it can make decisions more fair, because you're applying the same standards to everyone. But if you're not careful, it can also make it harder to realize when an algorithm isn't fair. Here's a very simple algorithm we can use as an example. Kidney transplants can give people many extra years of life, but because there are always more people who need transplants than there are kidneys available, somebody has to decide who gets a kidney and who doesn't. It's important that this decision be fair, so in 2007 doctors came up with this algorithm to decide it. KP means kidney priority, where someone is in the line to get a kidney. The higher your KP, the more likely you are to get one of the kidneys available. YL means years of life, how much longer you're likely to live if you get the kidney. So KP equals YL means that if you'll probably live 20 more years if you get the kidney, then you're more likely to get it than if you'll only live 10 more years. Does this seem reasonable to you? Does it seem fair? Why or why not? It looks pretty reasonable and straightforward at first glance, but think about this. How accurate a measurement of YL can you have? How can you know or guess how many more years someone will live if they get the kidney? The older someone is, the fewer extra years of life a kidney is likely to give them. Is it fair to give younger people a better chance at getting a kidney? Different groups of people have different life expectancies. For example, in many countries, groups that are discriminated against or have less access to medical care, such as Black or Indigenous people, have shorter life expectancies. Is it fair for people who already have a higher life expectancy to have first priority for kidney transplants? Once the people who were designing this algorithm thought about these things, they realized it would need to consider all of those questions. For instance, it now also considers how healthy the donor kidney is, so that younger patients are not necessarily more likely to get a kidney, but they will get a healthier kidney. That's because, while algorithms may look objective and neutral, because they use real-world data, they can often reinforce real-world biases. That means that if the data is biased in any way, those biases will be expressed in the algorithm. For instance, algorithms like Midjourney and DALL-E are trained more on stock photos than on actual photos, so the images they generate reflect the conscious and unconscious choices of the stock photo companies. As a result, these algorithms not only replicate existing biases, but are actually more biased than the real world. The prompt Native American, for example, results almost exclusively in images of people wearing traditional headdresses that are part of the popular image of Indigenous people, but are only part of the traditional culture of some Indigenous nations. And of course, were not part of anyone's everyday wear. AI algorithms aren't programmed but trained. That means they're given a goal, like making you spend more time on a website or deciding who should get a kidney. Then given a data set, like a list of people who got kidney transplants in the past and how long they lived after that. And then made to look for patterns in that data that they use to make a decision. This is why AI is sometimes called a black box, because unlike the kidney transplant algorithm, we don't always know why an AI made a decision. Even the people who designed it might not know. This can make biases even harder to spot. For example, one algorithm scanned thousands of successful and unsuccessful resumes and concluded that the most important qualities of a job applicant were that they played lacrosse and were named Jared. Luckily, the people who designed that algorithm realized it was biased and decided not to use it, but if it had, you might never have known that the reason you didn't get a job interview was because your name wasn't Jared and you didn't play lacrosse. As we've seen, one of the main reasons that people use algorithms and AI is to make choices. Sometimes, as with kidney transplants, it's to make those decisions more consistent and more fair. Other times, like when recommending videos, it's because millions of decisions have to be made every second. But how good is AI at making choices? Another thing that makes AIs different from simple algorithms is that they can change themselves. Imagine that an AI decided what you were going to eat and was optimized to give you the dinner you liked the most. It might do this by watching how much you ate of the different things it fed you and adjusting what you got based on that. If you didn't eat all your broccoli one day, it would give you less broccoli the next. And if you ate all your ice cream, it might give you more ice cream the next day. As time goes on, you'll get more and more ice cream and less broccoli. Eventually, you'll get only ice cream and no broccoli. If there are more than 2 elements of your dinner, you eventually will only get your favorite one and nothing else. You might like getting less broccoli and more ice cream, but it's not necessarily good for you. Most of the algorithms in our lives work the same way. They're optimized to give you things that will keep you using the app or platform that uses them. This is what's called a feedback loop. It can happen in places like YouTube or Netflix, where you get recommended more and more of the same stuff, even when you get bored of it, because the algorithm's model of what you'll respond to has gotten so precise. Because they also use the same algorithms to decide what content to pay for, content creators, whether that's people making videos for YouTube or TikTok, or production companies making movies for Netflix, make things in response to what they think the algorithm wants, which makes all of their content more and more similar as the algorithm zeroes in on what most users will respond to. What are some examples of ice cream that the algorithms in your life give you? Things that aren't good for you in large amounts, or maybe not good for you at all. What things does the algorithm feed you that make you feel worse afterward? You might think of things like clickbait or fake news, things that seem really exciting but are untrue or misleading. Things that make you angry or upset, things that make you feel bad about yourself, or things that make you keep watching or playing even when you know you shouldn't. To put it another way, what are some things you see a lot in your feed but regret reading or watching? What are some things you have to look for in your feed but that make you feel better? You might think of examples like real news, reliable information, things that make you feel good about yourself, or things that encourage you to do something healthy or meaningful. We already talked a bit about how algorithms get input, the information they need to make decisions. Let's look at an example of how that might play out. Imagine that you were designing an algorithm for an insurance company that wanted to know who was more likely to get in an accident. The more likely you are to get in an accident, the more you have to pay for insurance. Like the kidney algorithm, insurance companies already set prices based on demographic data. Men pay more than women for car insurance on average because they have more car accidents. But what if your AI knew what videos people had watched on TikTok or YouTube, what they'd bought at e-commerce sites like Amazon, or what they'd searched for on Google, and could match that with whether or not people had car accidents? The AI might match people's search, viewing, or shopping history with more or less risky behaviors. For example, buying a skateboard or watching skateboarding videos. This might be good for people who were seen as being lower risk because they'd probably pay less, but people who were seen as being higher risk would pay more. The data might let the AI make more accurate decisions than ones based on very broad categories like gender, but the connections it made might be inaccurate in 2 ways. If the data didn't mean what it seemed to mean, for instance, if you'd bought the skateboard for someone else as a gift. Or if the connection between one kind of risk and another wasn't accurate. You might like risky sports, but still drive very carefully. The fact is that nearly all AIs do work that way. They either use data that they collected about you, for instance, the prompts you enter into a chat AI, or information your computer automatically sends, like your location and internet protocol address. Information the company bought, either from another company or from data brokers that buy data from lots of places and put it together into profiles. or information shared between different parts of the same company. For instance, Google can use your YouTube views to decide what search results to show you and vice versa because they're owned by the same company. In other words, algorithms don't make decisions based just on what they know about you. They make them based on what they think they know about you. Now, you may have noticed that the algorithms we've been talking about don't sound that much like what you think of when you think of AI, things like DALL-E, ChatGPT, and Midjourney. These are examples of generative AI, and they do work the same way as other machine learning algorithms, but they draw on much more data and have much more complex models than even the AIs used by TikTok, YouTube, or Google. We'll use ChatGPT as our example. It's a kind of AI called a large language model. What does that mean? Well, let's go through the three words in reverse order. Model. Like other machine learning algorithms, most of ChatGPT's capabilities aren't programmed, but instead come from being trained on large amounts of writing. They find patterns in these to create a model of how language works. Language. It can read and write fluently, at the level of sentences, paragraphs, and even full articles. It does this mostly by looking at how similar or different words are in different ways or dimensions. For example, if we were to consider just two dimensions, roundness and redness, an apple and a fire truck might be very far apart on roundness, but close together on redness, while a baseball would be close to the apple in terms of roundness, but far away in redness. Chat AIs make guesses by looking along different dimensions. If one started at king and looked further away along the female dimension, it would see queen, while if it looked down the youth dimension, it might see prince, and looking in both directions might lead to princess. This lets the AI make better guesses about which words should follow each other based on other parts of the sentence or paragraph. For example, if you were to write, Frida had a drink of chocolate, autocomplete might always suggest that the next word after chocolate should be chips, because that's what follows the word chocolate most often in the training set. On the other hand, if you ask ChatGPT what kind of chocolate did Frida drink, it might spot the word drink and then look from chocolate along the liquid dimension and find that the nearest word in that direction was milk. But let's suppose we're starting with chocolate and looking along both the brown and liquid dimensions. If we add a third dimension, let's say edible, we're already reaching the point where it's hard to represent the relationships graphically and the limits of what most people can hold in our minds. But in ChatGPT, each word is given a value in up to 96 dimensions, and it does more than 9,000 operations every time it guesses a new word. It was trained on a dataset of around 500 billion words. That kind of scale is how chat AIs are able to mimic real language and real conversations. And ones like DALL-E are able to make convincing images. It's important to remember, though, that generative AI still works by making guesses based on probability and on similarity. The size of the training set and the sophistication of the models means they can make fluent content, and if the training set included the right answer to your question, you might get accurate information. But large language models are also prone to hallucinations, where they'll tell you with perfect confidence about things that don't exist. Now that we understand algorithms and AI a little better, let's go back to the 4 principles we covered. Algorithms can reinforce real-world biases. We don't always know how AIs make decisions. AIs give you what they think you want, not what's good for you, and AI makes decisions based on what it thinks it knows about you. Keeping those in mind, here are a few questions to consider. What kinds of biases might be found in the texts AIs were trained on? Think about social media posts or old books. how might that affect its responses? Should people who make AIs have to be able to explain how they work? How does their black box quality make it hard for designers to make safeguards or guardrails that might prevent some of the other problems? Are there topics or information you might want a chat AI to tell you, but that wouldn't be good for you? What could go wrong if you asked a chat AI for advice or told them about a personal problem? What could go wrong if you used them as a source of information? How do you think AIs get information about you? Do you think that's fair? Do you think it's accurate? What kinds of guardrails should be required for AI developers? In which decisions should we need a human in the loop? To wrap it up, here are a few tips to help you use AIs safely and ethically. For ethical reasons, never present AI written work as your own. Talk to your teacher before using a chat AI in your work. If you use AI in your work, show clearly where and how you used it. Don't use chat AIs for research, because you can't know how accurate the answer will be. Think carefully about what you say or write when using chat AIs. Remember that the company can save and read all your prompts, and that they may affect how the AI acts later, and that things you say now could affect anything from your search results to whether you get offered a job 10 years from now. Find out how much data the AI collects about you and what you can do about it. Look it up at tosdr.org to see a summary of its privacy policy. If it isn't listed there, go to the privacy policy and look for a title like How We Use Your Personal Information. Then look for a title like Your Choices or Your Rights to see what options you have, if any. Limit how much data AIs have about you. On an iPhone or an iPad, use the Ask App Not to Track setting. You can also use apps like Blockada or DuckDuckGo and browser plugins like Privacy Badger or Ghostery to stop apps and websites from collecting data. Remember that while talking to them can feel like talking to a real person, chat AIs are just simulations that guess what you want to hear. Treat them like a toy, not a friend. Chat AIs can be a lot of fun, but just like everything else you do online, make sure they aren't taking time away from important things like friends, family, school, sleep, and exercise. If you're interested in finding out more about algorithms and AI, or want to explore some of the issues we've talked about, here are some activities you can try. Fact-checking AI. Ask a chat AI a question about a topic you know a lot about. How accurate was the result? How well did the result show an understanding of the topic? Did it over or underemphasize the importance of certain facts or express common misconceptions? Do different ways of phrasing the prompt lead to more or less accurate results? Getting references. Ask a chat AI a question about a topic and ask it to give references to scholarly sources. Now look up the sources yourself. How many are real? How many have the correct authors and publication info? Picturing bias. Have a graphics-based AI like Midjourney or DALL-E make pictures of different jobs and occupations. What patterns do you see in terms of things like race and gender? Do other graphics AIs have the same pattern?